has given a single line diagram, okay, with three generators. This is G1, G2 and G3. Let us take three transformers, T1, T2 and this transformer as TT, and we have a transmission line in between these two buses. Now if a fault occurred in bus 1, let us take this as bus 1 and this as bus 2. If a fault occurs in bus 1 at this point P, now what is the line to line fault occurred at point P and find the fault current. This is the question. Now what is fault current? IF in LL fault, it is given as fault current in LL fault is minus J root 3 into voltage at fault point by J times of positive sequence reactance up to the fault point plus J times of negative sequence reactance up to the fault point. Okay, now let us take voltages at these buses as 1 per unit. Okay, now we have to draw positive sequence network as well as negative sequence network to find this reactance up to fault point. Remember that when you are drawing positive sequence and negative sequence reactance diagrams, it is taken with respect to neutral n, whereas this is for positive and negative sequence. Okay, whereas zero sequence reference is taken from ground. Okay, this is for zero sequence. Now what is the reactance diagram for positive sequence network is, okay, we have a generator G1. Active elements is represented source in series with reactance, whereas static elements, or you can say it as passive, okay, that will be represented with respect to only reactances. Okay, now this is generator 1 and generator 2. Let us take this is EMF E1, EMF induced E2. These are all dynamic equipment, so it is represented in series with reactance. So this is generator reactance. He has given positive sequence value as 0.4 per unit. So this is, we are drawing positive sequence network. So this is 0.4 per unit, and this is transformer reactance. He has given it as 0.1 per unit. Similarly for generator 2, positive sequence reactance is given as 0.4, whereas transformer reactance is 0.1. Now in between we have a transmission line. Okay, that means transmission line is represented with only reactance since it is static one. Okay, we know here from this positive sequence reactance as 0.4 per unit. Okay, after that we have transformer, positive sequence value is 0.4 for this transformer. Okay, no, he has given the transformer reactance, all of this as x0, x1, x2 as 0.1 per unit. Okay, so this is replaced with 0.1. In generator we have generator 3 here, so we have to represent it voltage source in series with generator. This is neutral point N. Okay, this is neutral point N. Now this value he has given positive sequence 0.4 per unit. Let us take it as EMF induced G3 is all as 1 per unit. Okay, now fault point is P is from bus 1. Okay, so this is fault point. Now we have to find reactance up to the fault point. Okay, this is x1 F. From this we can calculate x1 F, that is reactance up to fault point, as 0.9 parallel to 0.25, which is equal to 0.195. Okay, similarly we have to draw negative sequence network. Okay, now since negative reactance diagram is also drawn between phase to neutral, but you don't have any sources in negative sequence diagram. This is fault point. P. This is transformer reactance negative sequence is 0.1. Generator negative sequence is given as 0.2. Similarly, transformer to negative sequence is 0.1 per unit. Generator's negative sequence is generator to negative sequence is 0.2 per unit. We have transmission line in between these two buses. Negative sequence value given as 0.4 and transformer 3 negative sequence value is 0.1 and generator 3 negative sequence value given as 0.2. Now what is negative sequence reactance up to the fault point? So here X2F is given as 0.15 is in parallel to 0.7. So this is 0.123. Now what is fault current in LL type fault? Minus J into root 3. This is VF is 1 per unit. J times of X 1F, that is up to the fault point. So this is 0.195 plus J times of 0.123. Okay. We will get this ratio as minus 5.43 per unit. Okay. Now next question is we have to find ratio of line to line fault current and three phase line fault current, that is LLL fault current. Okay, this question 5.43 per unit, option A is correct. Now next we have to find fault current for LLL fault current of triple L fault ratio. Okay, now we know that fault current in LLL fault is given as V by J times of X1. Okay, since this is 1 per unit, J times of X1 is 0.2. Okay, this is given as minus J 5 per unit. Okay, now what is the ratio here? This is minus 5.43 by minus J times of 5 per unit. Okay, we will get it as minus J times of 1.086 per unit, that is option C is correct answer.
Question is, consider the following circuit. Assume large time constant RLC. Assume it is a silicon diode, means whose forward drop is 0.7. So when we if we look into the figure, it looks like a negative clamp, means it will shift the complete waveform towards the negative side. Means the capacitor, initially the voltage across the capacitor is charged to 12 minus 0.7, which is 11.3. Means V0 is nothing but Vi minus Vc. So it is going to be minus 12 minus 11.3. when Vi is minus 12, that is minus 23.3. hence option C is correct. Here we know that from the above circuit, V0 Vi minus Vc is nothing but a V0. We know that Vc is nothing but 12 minus 0.7 is 11.3. Here when it is 12, Vi is plus 12, we will get 0.7. When Vi is minus 12, we will get minus 23.3. Hence the peak to peak swing is 24 volts. Hence option A is correct.